Hi everyone, we're going to continue on our discussion of atoms, ions, and molecules. In the previous topic, in the previous video, we talked about this idea of the atoms and how we can write the mass number and the atomic number of the element. I should point out that I made a mistake in the previous video in terms of the symbol. So I said the atomic number was A, but and the mass number was Z, but I actually flipped this. So make sure you correct this in your notes. The atomic number has the symbol Z, and the mass number has the symbol A. But aside from that, the description of these, parameters, atomic number and mass number, is correct, except that I used the wrong symbol to indicate them. Okay, so let's just quickly talk about how this is done. Generally speaking, when you're giving information about an isotope, a lot of times you would write it as this form, which is the X here represents the atomic symbol. For sodium will be Na, for lithium in this case will be Li, and so on. And then you put your atomic number at the bottom left side, and then the mass number at the top left side. So here's an example of 3 lithium isotopes. Lithium, by definition, for something to be called a lithium, for an element to be called lithium, it all has to have 3 protons. So the atomic number, as you can see, for all 3 of them are identical, which is 3, and then they just differ by the number of neutrons. So you can see here that in the illustration they all have 3 protons in the nucleus, right? And then for this one it has 3 neutrons. So as a result, 3 plus 3 is 6. That's why the mass number is 6. In this case, the mass number is 7 because I have, what, 4 neutrons. So the number of protons can't change. That's very important. The number of neutrons can in an isotope. And then here you have 5 neutrons and 3 protons as well. Notice also what stays the same here in this picture. The number of electrons, which is shown by these little red dots here, they stay the same. Now, in theory, of course, this is really not drawn to scale because the nucleus is really small, right? It's condensed to a very small volume of the atom, and the atom is really much bigger than this. But, this is just to kind of illustrate the number of particles that you have. So now we're going to talk about ions. So an ion is just an atom that has lost or gained electrons. Notice here that it's electrons that are lost or gained, not the other subatomic particles. You can't lose protons, you can't lose neutrons, but you can lose electrons, okay? So a cation is a positive ion. How is an atom become a positive ion or a cation? By losing electrons, right? If you lose electrons, you lose negative charges, so you become more positive because initially you have equal number of positive and negative charges. If you lose the negative, you get the positive dominates, so now you become positively charged. Same thing with anion. Something becomes an anion if it gains electrons from, let's say, an atom that loses electrons. Okay, so an anion is just a negative ion. Here's just kind of a quick picture to show how that happens. So let's say you have a neutral atom originally, which is shown in this yellow illustration here, and then there is some kind of energy that hits that atom. It could be an X-ray, it could be light, it could be light of a certain wavelength, which is what X-ray is, but it could be some other source of energy that basically knocks the electron off this atom. The electron then gets, is floating here, right? And so what's remained of this element is now a positive ion. So that's what the cation is, because now it has more protons than electrons. The electron, on the other hand, could then jump on to another atom or a neutral molecule, but it could be another atom. And then as a result, this thing now becomes an anion. So then you have a positive ion and a negative ion. We'll talk about the next topic, which is the combination of these two to form an ionic compound. But that's how ions form. Okay, so what type of ions would you see in terms of, when I talk about it in class? I'm gonna use this term monoatomic ions to talk about ions that basically has just one atom in them. So for example, the Cl- ion, Na+ ion, O2-, Fe2+, Fe3+, all of these are monoatomic. You see that there's only one element here. We also have a list of polyatomic ions, which basically just means ions that have more than one element in them. So SO4 2-, the entire unit here of SO4 sulfate has a charge of 2-, so it's called polyatomic. NH4 plus, ammonium ion, all of these guys has a total charge of +1, and so on. This is oxalate, C2O4 2-. This polyatomic ion is not something you can, really derive at this point, so you just have to memorize them. That's basically the easiest way to go about this. The list of polyatomic ions that you have to memorize is provided in the inorganic nomenclature lab manual. So when we do this lab, which is going to be on the second week of your lab, you'll see that there's a sheet as part of the lab manual that consists of various polyatomic ions, and you have to memorize all of those. Now, in the next section, which will be on the periodic table, I'll talk about how you can easily determine the charge of monoatomic ions, whether they're going to be positive or negative, and what kind of whether they're going to be +1, +2, +3, or -1, -2, and so on. Just a general rule before we get to that periodic table section, that the cations come from the metallic elements. So the metallic elements are all located on the left side of the periodic table. So those elements, when they become ions, they become cations. And then the anions come from the nonmetals, which is the right side of the periodic table. So when those elements become ions, they become anions. Let's now talk about these terms compounds and molecules. So as it turns out, atoms and ions, they exist, but generally they not a lot of them exist on their own, but there are more of them that combine with each other to make larger chemical species. So atoms can combine with other atoms to make larger chemical species. A cation can combine with an anion to make a larger chemical species. They do this by forming what we call a chemical bond. Okay? Now, what kind of chemical bonds can they form? There's two types that we're going to mention here briefly. An ionic bond is basically a bond, and a bond, when I say the word bond, really what I mean is it's the electrostatic interaction, and that's what we call a bond. Now, what is electrostatic interaction? This is a term that we use early on when we talk about the history of the nuclear model as well. The electrostatic interaction is just a positive-negative interaction, which is what that means. It's just, same charges repel, and then opposite charges attract. Okay, that's all you need to know. That's what electrostatic interaction means. So an ionic bond is basically this type of interaction, electrostatic interaction, between a cation and an anion. It could be between several cations and several anions, but usually defined as a single interaction between one of each type of ion. A covalent bond, which is a different type of chemical bond, is also an electrostatic interaction, but this is resulting, instead of a interaction between a full ion that's positively charged and a full ion that's negatively charged, electrostatic interaction results from the sharing of electrons between two nonmetals. As a result of this sharing of electrons, there is attraction between the nucleus in one atom with the electrons, and then nucleus in the other atom with the other electrons as well. So that interaction is what we refer to as the covalent bond. So let me just show you a real quick illustration of this. An ionic bond, as I said earlier, is an interaction between a positively charged ion, a cation, and an anion, right? So when you transfer that electron to the other atom, this guy becomes a cation, and now it has a positive charge. So the positive charge can interact with the excess negative charge in this ion, and that interaction is what we refer to as an ionic bond. Now, a covalent bond, on the other hand, is the sharing. So these two atoms, they come together, and they share their electrons together. Now, the electrons are then have electrostatic interaction with the two nuclei. Okay, so there's attraction between this guy and that guy, and there's attraction between this and that results in holding of these two atoms together, and that's what we refer to as a covalent bond. So going back to the idea that these atoms and ions can make larger chemical species, we call these larger chemical species special names. So if it's something that is formed by an ionic bond, we call it an ionic compound, which is basically, the definition of this is an electrically neutral species. So an ionic compound is neutral from an charge perspective, composed of cations and anions. So an example of this is that the cation is +1, the anion has to be -1 in order to make it electrically neutral. Okay. Now a covalent molecule, on the other hand, it's a larger chemical species that is composed of 2 or more nonmetals. And again, remember I mentioned earlier, nonmetals are located on the right side of the periodic table, and we'll show that location when we talk about the periodic table.